Foundations of Virtual Beings introduces the essential building blocks for virtual beings, including the tools used by creators, the environments in which avatars operate, and the delivery methods for audiences. It explains how cognitive architecture, dialogue systems, behavior realizers, and interaction engines drives believability, while also addressing the computing infrastructure that underpins these systems, from CPUs and GPUs to cloud engines and distributed platforms. This slide outlines a layered conceptual model for digital humans and avatars within artificial reality environments. At the top sits artificial reality, the encompassing space of immersive technologies such as VR, AR, and MR. Beneath it is the avatar layer, which provides the framework through which digital representations of humans are experienced. Within this layer, the model distinguishes between two levels of digital humans. First-level digital humans, human-inhabited avatars, where a real person directly controls the avatar, and second-level digital humans, AI-inhabited avatars, where artificial intelligence generates the avatar's behavior. Supporting these are two key systems: 3D telepresence, which enables real-time remote embodiment and interaction, and social simulation, which allows AI-driven social environments and interactions. The combination of 3D telepresence plus social simulation represents the integration of real human presence with AI-driven virtual societies, forming a hybrid layer that bridges live human control with autonomous social systems. The diagram, therefore, shows how different forms of embodiment and interaction build on each other to create increasingly complex digital human ecosystems within artificial reality. This diagram presents a layered framework for building a virtual human, dividing its makeup into body and mind, both supported by machine learning. The mind is represented by conversational AI for hearing and talking, and emotional AI for understanding and responding to emotions, while the body is shaped through computer vision for sight and body language for expressive movement. Together, these components simulate human-like presence, perception, and interaction, showing how AI subsystems integrate to create virtual beings capable of communication, expression, and emotional awareness. This diagram illustrates the relationships between virtual characters, virtual robots, and physical robots, positioning them within broader conceptual categories of virtual beings and cyborgism. Virtual characters connect downward to virtual beings, emphasizing their existence as purely digital entities, while physical robots connect downward to cyborgism, highlighting the fusion of humans and machines in physical form. Virtual robots occupy the middle ground, linking both sides by sharing traits of digital autonomy with virtual beings and embodied presence with physical robots. The structure shows a continuum where virtual and physical systems intersect, suggesting that virtual beings and cyborgism represent complementary extensions of digital and robotic evolution. This diagram outlines the ecosystem of a virtual human, framed between the creator who develops it using tools and the consumer who experiences it through delivery systems. At the core is the virtual human environment, which relies on three key components: tools, the toolkit used by creators, the environment/engine, the platform where the virtual human operates, and delivery, the channels through which consumers access it. The final layer highlights how this ecosystem can be powered by a cloud game engine and enhanced by 5G connectivity, enabling real-time creation, deployment, and interaction at scale. The model emphasizes the interplay between creation, environment, and distribution in sustaining virtual human experiences. This diagram depicts the core structure of a cognitive architecture for virtual humans, dividing it into two complementary components: the dialogue system, which manages verbal communication such as speech recognition, natural language processing, and spoken responses, and the behavior realizer, which governs nonverbal communication like gestures, facial expressions, and body language. Together, these systems enable a virtual human to engage in both spoken interaction and expressive, embodied behavior, creating more natural human-like communication. The overarching cognitive architecture integrates these elements, coordinating verbal and nonverbal modalities into a unified interactive experience. This diagram distinguishes between two levels of virtual humans: the first level, where digital doubles like Meet Mike and DigiDoug are controlled by humans through real-time graphics pipelines and act as digital puppets such as VTubers, and the second level, where the human operator is replaced by automation. At the second level, virtual humans require at minimum a spoken dialogue system and behavior realization for body language, with more advanced systems incorporating computer vision as a sensor and emotional intelligence, enabling them to function as autonomous AI-driven entities rather than human-inhabited avatars. This diagram maps the technological ecosystem supporting game engines and virtual experiences, showing the progression from local to cloud-based infrastructures. At the top, software runtime (CPU) and graphics pipeline (GPU) represent the traditional hardware foundations for running applications and rendering graphics. These connect to the edge in desktop game engines, which manage real-time interactivity closer to the user. Moving further, the cloud and cloud game engine shift processing to remote servers, enabling scalable computation and resource sharing. This feeds into game streaming, where users access high-quality interactive experiences without local processing. The example of Google Stadia highlights this cloud-first model, built on Linux instances and multi-GPU infrastructures, illustrating how cloud game engines and streaming services redefine delivery of virtual and gaming content. This diagram contrasts human-inhabited virtual humans, VH, with AI-inhabited virtual humans, showing their structural parallels. On both sides, the avatar is the outward representation, but the control differs. Human-inhabited VHs are driven by a human operator, while AI-inhabited VHs are powered by artificial intelligence. For human-driven avatars, communication relies on body language and natural language from the operator, whereas AI-driven avatars use a behavior realizer to generate nonverbal actions and a dialogue system to handle verbal interaction. Together, the diagram illustrates how both approaches share the same avatar interface, but differ fundamentally in the source of intelligence and expressive capability, human versus AI.